installed, and you can do, quote, the coverage test. And during those 2 times, you'll be taking notes about the condition of the system, if there's been any breaks or leaks, or if there's something that's just not part of your design. You'll be doing this punch list. And then what happens after the punch list is done, it goes to the contractor. The contractor then goes to fix the items that were on your punch list, and after that, then you come back and do a back check. So ideally, to check an irrigation system, you want 3 visits, and they're time consuming. So you want to put that in your bids. So one of the other things that before you go out and do any of the inspection, you want what's called submittals from your contractor. And that's cut sheets of the products that you've specified. And if the contractor does some substitutions, you can agree to them if the product substitution is as good as you've specified or better. If you're doing a job for, say, a city or a municipality, generally they have products that they want on their projects. So if the contractor's trying to change that, you tell them no, they can't do that. So actually, how I'm going to do this tonight is talk about the components of the irrigation system, and then we'll go back and talk specifically what to look for in each of these components when you're out in the field. So the first part is we want to talk about the point of connection, and that would be your water source or your water meter. And for tonight's presentation, I just want to talk about projects that have water meters. That would be recycled water or potable water. There's other types of water that can be used for irrigation, like rainwater or condensate water or well water. And with those different types of water for your water source, you would have components that are a little bit different than what we're going to talk about today. These other water types, if anybody wants to have another presentation on what to do with well water, we can certainly do that another time. So after your water meter, we would have a backflow preventer, reduced pressure backflow preventer. And this has to be on every single job. And it has to be right after the water meter. And then after the backflow preventer, if you don't have enough pressure, you would need a booster pump. But I want to take that out of this part of the discussion, and we'll talk about it a little later. And then after the booster pump, but let's take that out, but after the backflow preventer, there would be your master valve and flow sensor. And the reason we have that in there is today, because of the water ordinances, more of the cities are requiring, or the water ordinance, they're requiring that you use smart controllers. And along with the smart controllers come the master valve and the flow sensor. So all of the above are POC, or point of connection components. And that's when you're out in the field, that's where you're going to start looking at things. Now next, I mentioned the controllers, and we have what's called smart controllers, and that's where they are what we call weather-based controllers. And today, that should be the only kind of controller that you should specify. And pretty much now the manufacturers they don't have very many dumb controllers anymore. Now there's conventional controllers, and when I mean conventional, I mean by the wiring. That's where every single station has a wire that goes to one valve, and a common wire that goes to all valves. And then there's 2-wire controllers, and that's where there's only 2 wires coming out of the controller, and it goes to every single valve, and each valve has like an address, a little decoder, and that's how the station or the controller programs its stations. And we'll probably be seeing two-wire as a common controller now. Okay, so we go back to the items that are after your flow sensor, and that would be your main line. And then connected to the main line are the remote control valves, quick couplers, gate valves, and ball valves. And then after your remote control valve are the lateral lines that go to the sprinklers and drip or whatever you've specified. Now, a few other items that you'll be looking at will be filters, and they may be at the beginning of your system or on the valves or in the heads even. And then there's pressure regulators. If your pressure's too high, then you'll need pressure regulators. And then there's other sensors like rain and freeze and wind, and then as well as weather sensors. And then there's your irrigation wire that you will make sure that is running, that runs along with your main line. And wire connectors, flush plugs, air relief and vacuum valves. And then what's not on here is fertilizer injection. We're seeing more and more of that being used on all jobs. Okay, so after we talk about these components, now I want to talk about the things that you should be looking for out in the field, and I'll tell you when you can see them during installation only or during water coverage only. So we'll go to the water meter. Now, the first thing about water meters is that before you start your design, you will have called the water agency that is feeding your project, and make sure that you get, when you call them, you'll ask for the water meter size and the static pressure, and make sure that you put down the person's full name and the date, because when you go out into the field and check the water meter, it's not always possible to get the cover up. It's a concrete cover, and it takes a special tool for that. So you just have to rely on what the water agency told you. Joe, do you have the pointer? May I have that, please? Joe is one of our associates. Okay, thank you. Now I have to figure out how this works. So if you see, this is supposed to be the water agency building. So you would call them, get your water pressure, and static water pressure and the meter size. And again, up here, make sure you give them you get their full name and the date. Believe me, that many times that saves us when we can't look at the water meter out in the field and find out it's a 1 inch rather than a 2 inch. Okay, so this is an actual water meter right here, and then just pictures of other types of water source. Okay, after this should be, wait, let me do, all right, well, after your water meter, maybe the computer works better than my clicker. After the water meter is the backflow preventer, and again, as I said, it's needs to be put on every single system. It's a code now, and the water meter, the backflow preventer has to be no more than 5 feet from the water meter, and that's a code also. So you have to double check with your cities. Now, the backflow preventer, you don't necessarily have to be out there during installation to be able to check the backflow. If you were only out there for water coverage, you can check the backflow at that time. But on the backflow, there are these little devices called petcocks, And when you go out into the field with the contractor, he will take the enclosure off for you. This right here, that's the enclosure, and that's the backflow. The details are pretty detailed. I don't know if you can really see all this, all the detail. But on the backflow preventer, there's a petcock, and you can get a gauge with a 1/4-inch fitting on it and screw it into the petcock that's on the upstream side of the backflow preventer. And then you need a screwdriver to turn on the petcock, and then the gauge will read what your static pressure is. And your static pressure is the pressure that you'll be starting your hydraulics from. And we won't go into hydraulics tonight because that really is a whole nother discussion. So we'll go from getting the pressure at the backflow preventer, and if for some reason or other you're out in the field and the contractor's not there, or you can't get to the backflow, another way of checking your pressure is to specify a quick coupler right near your point of connection and get a quick coupler key, which is this right here. That goes into the quick coupler, and the key that you get has to be the same manufacturer as the quick coupler. And you get this quick coupler key, and you put a ball valve on it and then a gauge. Screw it into the quick coupler, and then you'll get your static pressure that way. And if you don't have these gauges, you can go to like John Deere Landscape or any of the supply houses that have irrigation, and they can make up these devices for you. Just tell them what you want it for. And another thing to look for when you're out in the field is that the backflow has to be 12 inches above grade. And then on the backflow, there will be written the manufacturer's name and the size of the backflow. So check that is what you've specified. And then also the backflow should have a concrete pad. It should not be just stuck into the dirt. Okay, so let me try this again. Oh, we'll do this. Okay, the next items that you'll be checking will be the master valve and the flow sensor. Both these items need to be wired to the controller, and when you're out in the field, the master valve and flow sensor are right downstream of the backflow preventer. The master valve will be the first item in a box. It'll be in a valve box. And you'll take the cover off the valve box and check that the master valve is the size that you specified and the type. The way to get familiar with what sizes look like is just have the manufacturer come in and give you a demonstration on their master valve and what size looks like what size. The next thing after that would be your flow sensor. And the flow sensor, you can see right here there's a section of pipe and another section of pipe. The flow sensor needs to be installed with these certain lengths of pipe between the master valve and the flow, or actually between this fitting and the flow sensor, and this length of pipe and this fitting. This one has to be 10 times diameter, or the flow sensor diameter. This has to be 10 times that length with no fittings in it, and downstream it needs to be 5 times the diameter of the flow sensor. And the reason for that is that the water needs to be smoothed out so that the flow sensor is reading the gallonage correctly. Then also you'll see, and this will be true of all valves, they need to have pea gravel, and it has to be nicely put in there in the valve box. And if you see boulders in there, tell the contractor to take them out and put pea gravel in. And then all the valve boxes are supported by bricks on all four sides, so look for that. And then I like to see, and we don't have this on this detail, but I like to see a tag on the master valve that says MV, so the maintenance people know exactly what it is. And the same thing with the flow sensor. And you'll notice too that the valve boxes are right flush to grade, and contractors sometimes tend to just slap them in the ground, and they're awkward. I mean, they're sticking sideways, and so make sure they're nice and straight. Okay, as far as what you can see during installation, it's okay to go out on the site and look at the master valve while you're doing water coverage. You don't necessarily have to be there during installation, but on the flow sensor, because of the lengths of pipe, you'd have to be out there during installation to make sure the contractor has done the correct lengths before and after the master valve. Okay, so all these items, the water meter, the backflow preventer, the master valve, and the flow sensor are what we call the point of connection. And that's when you go out into the field, that's where you start, is at your point of connection. That doesn't work. So the master valve and flow sensor, I said, have to be wired to the controller. So when you go to your job site, look and make sure your controller is in the proper place that you put it on your plans. It has to have 120 volt electrical to it, and that's normally put in by an electrical contractor. The irrigation contractor is not licensed to handle 120 volt. So at the controller, here's 120 volt coming in, and then these are the 24 volt wires coming out, and there's a transformer there that transforms it from 120 to 24. Now, when you're out in the field looking at your controller, if you've specified a enclosure for your controller, make sure it's the right enclosure. If it's a pedestal mount or a wall mount, check to make sure that it's what you've specified. Now, this is another reason why you need the contractor to be with you, because the contractor will have a key to the controller or the enclosure, and then you want the contractor to open up the panel. This would be the panel. Open up the front panel of the controller and look inside, and you'll see hopefully you'll see the connection for the master valve and the flow sensor. And then you'll see with a conventional wired controller, you'll see a common wire that goes to every single valve, and then the wires that go to each controller. Now, if you don't see the wires to each valve, if you don't see that wired up, then you will not do a water coverage test. We want all valves to operate from the controller. And hopefully on your jobs you'll spec handheld remotes for the contractor, and so when you're out in the field they can just remotely start the controller for you. Now this controller, I said, is a smart controller, and you'll see right here is a weather station, and that weather station reads the evapotranspiration rate. Do you know what that is? The evapotranspiration rate, okay. That reads and sends to the controller, and these are wireless. There's more and more of them that are wireless. So then that feeds information to the controller, so that the controller is programmed based on what the weather is. Okay, so the controller is kind of the mind of the irrigation system. So it's, yeah. Oh yeah, Janet's going to chime in when I forgot. Oh right, when we when we design a system, we always design in extra wires, and for maybe a small project, you might only need 2 spare wires. So you want to make sure they're there. But for larger systems, we sometimes say 1 spare wire per 6 stations. And that spare wire will run the whole length of the main line. So just in case sometime in the future there's additional planting that needs to be done, then irrigated. Okay, so the other thing about controllers is get with the manufacturer of whatever controller you specify, and learn how to program the controller. So when you are checking this controller with the contractor, you can also check his programming and make sure it's what should be programmed into the station based on your water calcs. And we'll talk about Janet will talk about water calcs a little bit later. Okay, next would be the other components. And we'll start with the main line. The main line, there's different types of main line. There's Schedule 4, that we usually use in irrigation. Schedule 40, Class 200, and Class 315. Now the Schedule 40 and the Class 315 are what we call solvent weld pipe, and they're put together with glue. And Class 200 is usually used if your job requires main line to be 2.5 inch and above. So that's gasketed pipe, and what happens is one end of the pipe goes into another end that has a gasket, and that's what seals the pipe. Now the other thing that is done with the main line is that a pressure test needs to be done, and again this pressure test and looking at the type of main line can only be done during installation. And it's a little hard to see, but right on the side of the main line, or any PVC line, is actually the size of the main line and the type of material it is. So when you're out in the field during installation, look for that. Now on the pressure test, again, that can only be done during installation. And the contractor can put soil over the straight lengths of pipe, but wherever there's a fitting, like right here, that has to be open so that you can see that during the pressure test. And the pressure test is usually done by pumping up the main line to 125 psi, and at the end of the main line there's a cap and a pressure gauge. So the pressure test is run for 2 hours on solvent weld pipe. And after 2 hours, if there's been no PSI loss or maybe a couple of PSI, then the main line's ready to be buried. If the pressure is less or more than 2 PSI loss, then you need to walk that main line and check all the fittings and see if something's leaking. And you write that down on your punch list, and the contractor has to go back and install the brand new fitting and not just try and use glue or a Band-Aid to try and fix that fitting from leaking. Now if you do have ring type pipe, there's a whole different way of testing that, and there's a huge long formula, and we won't get into that right now, but if that's something you will need for any of your projects, just feel free to call us and we'll just send you the formula. Now going back to the pressure test though, if you're doing a municipal project, usually the city inspector wants to do the pressure test. So then you just make sure that that's been done. And then this picture right here is just showing, here's the flow sensor and then the main line's coming out of there. Let's see. Okay, on the next thing that you'll look at will be your remote control valves. Excuse me. And the remote control valve does not have to be inspected during installation necessarily. You can look at that during your water coverage test. You can take off the valve cover and look for specific items. So these specific items that you would be looking for would be that the valve box be flush to grade, then take off the cover and look in the valve box, make sure there is the pea gravel and the supports. And what we do for ease of maintenance, we have a ball valve before every valve. That way, if there's something wrong with that circuit of sprinklers, the contractor or the maintenance people, all they need to do is turn off that ball valve. Then they can work on it and the rest of the system will be operating. So I always say specify that and then make sure it's there in the box. And then here's your remote control valve. And sometimes you might need pressure regulation if you've got too much pressure, or if you've got, say, a system that you're running sports fields or large turf areas which need a lot more pressure to the head, but to your spray heads you don't need that much pressure, then it's important to put pressure regulation on the valve. So you would look for that on the valve. And then the other thing to look for is that the wires are nicely coiled and they need to be about 24 or 36 inches long, and that allows during any maintenance or repair, it allows them to have some leeway to pull the valve out. The other thing that's important is the tag. Every single valve needs to have a tag, and on that tag it will be the controller designation and the station designation. So whenever you open up the cover, you know what station that valve is. Also, for reclaimed water, that tag needs to be purple. Anything that's reclaimed water, you have to have purple or lavender. With potable water, it can be yellow. And, the wire connectors. The wire connectors are these little items right here. And those wire connectors need to be gel filled. They can't, those little caps that screw onto wires to put the wires together? Those are not allowed. They're not watertight. So look that you've got gel-filled wire connectors. Okay, after the remote control valve, we're going to talk about the lateral lines. And the lateral lines come from your remote control valve to your sprinklers. And we'll talk about what to look for in your sprinklers in just a little bit. But the lateral lines, you can only really see those or inspect those during the installation time. If you're only out there for the water coverage, the best way to check lateral lines is just to walk through the circuit. And if you start sinking in, you probably have a break in a lateral line. So it's just, look for soggy soil or water bubbling up. Okay, next on the main line are your gate valves and ball valves, and they can be used interchangeably. Some cities say they want ball valves, and some cities say they want gate valves. And these are to be placed where you've put them on your plan. And you, let's see here. On your plan, you usually put gate valves or ball valves at any place where your main line is crossing a street or a major parking lot. They're also used to section off parts of your main line so that if there's maintenance that needs to be done over here on this section of main line, the contractor can turn that off and still allow the rest of the system to operate. So don't forget to put ball valves and gate valves on your design. And then this is a gate valve, and it usually comes with a wheel top. This ball valve has a handle, and both of these valves have to be in valve boxes. And if you do have a ball valve with a handle like this, you need a larger valve box than what you would need if the ball valve has a handle like this. You can specify the ball valve with a wheel handle. Now, out in the field, you can still look at these items when you're doing water coverage tests. You don't necessarily have to be there during installation. So quick couplers are another thing that come off the main line, and quick couplers are usually spaced between 80 and 100 feet apart, or you put them in a place like a trash enclosure or somewhere where washing off of the hardscape is important. Now the quick coupler, the thing to look for when you're out in the field is to make sure that it's stabilized. And this particular detail, where's my little thing? This is a stabilizer. I call it a wing thing, but it goes around the quick coupler to stabilize it, because contractors and maintenance people are pulling hoses on it, so you need to have some stabilizing. You don't have to use this device, but at least there has to be rebar to stabilize that quick coupler. And the other thing on quick couplers is this top should be purple, whether you're using recycled water or not, because we don't want people drinking out of quick couplers just in case. Say they're injecting fertilizer into the system. You don't. The purple means do not drink, so we always do purple. And then, so you can look at the quick coupler during your water coverage walkthrough, but this item right here is what we call the swing joint, and that means that the item can have a little bit of give if something runs over it, and the swing joints are on valves, quick coupler valves, and on all your irrigation heads. In all the years that Janet and I have been in business, we have seen an incredible change in products and in installation. And many, many years ago, all heads and quick couplers were just connected directly to the pipe. And so if anything pushed down on that, you were breaking your lateral line. And what happens now, that this allows for that product to go up and down. So look for that if you are out during your installation time. And of course, the quick couplers again are in valve boxes. So we'll talk a little bit about valve boxes. As I said, you have a valve box for all the valves, from remote control valves to quick couplers to gate valves to ball valves, air relief valves. All valves have to be in a valve box. And the valve boxes are either a rectangle like this one, or for some of the smaller items like smaller gate valves or smaller air relief valves that are on drip, they would go in a round box. And what to look for in a box, and again, you can do this during the water coverage test. You don't have to be there during installation to see this. But in your valve box, or in the valve, where's my thing? Oh, here it is. Notice how neatly this is installed. That's what you want to look for out in the field. Make sure the box is flush to grade. If you specify gopher wire, make sure that's in the box. You see your pea gravel, and you see the supports at all four sides of the box. And this happens to be showing a valve that has the ball valve, the remote control valve, a union, and the valve boxes also come in different colors, either green, brown, or tan, and black. And depending on what your client wants, you can choose any of those colors. If you have purple, that is for your reclaimed water, and it means don't drink from the purple box. The thing is that when you have recycled water, you cannot get away from the purple, and it really doesn't blend in with any of your landscape. But you know, it's part of what's mandated right now. Okay, and valve boxes too. If you've got valves grouped together in some areas, make sure the contractor leaves about 12 inches between from one box to another. It looks nice in the landscape. Also, your valve box should be installed in shrub areas, not in lawn. Okay, sleeves you can only see during installation, and sleeves are what you need for your irrigation pipe to go through whenever you go under hardscape. And here's just an example of a 6-inch sleeve, and main line and lateral line on some projects go through just one sleeve, and then your wire goes through another sleeve. A lot of agencies prefer that. Again, it's something you can only see when you're out during installation. If you're not there during installation, you're just going to have to believe you've got a good contractor that knows that you should put sleeves under hardscape. After sleeves, we'll talk about the depth of main line and lateral line. And normally, it's 18 inches for main line, 12 inches depth for lateral lines, and 24 inches for sleeves. And that measurement is from the top of the pipe to the finished grade. If it's supposed to be 18 inches, that's top of pipe to finished grade, not bottom of pipe. Now, if you're doing work for a municipality, the municipality may be saying that your main line has to be 24 inches and your lateral line 18. So before you design a job, make sure you check with any agency and what they require for main line and lateral line. Now we're actually coming to the time when we're going to do our water coverage test. And as I mentioned before, all remote control valves have to be wired up to the controller while you do the water coverage test. And if they aren't, you just say to the contractor, no, we're not doing the water coverage test now until you have everything wired up. So let's say we're walking now with the contractor, we've checked the other items, and now the contractor, we tell him, let's start at the beginning, go to controller A, station 1. And let's, for this system, we'll just say rotors are number 1 circuit. So to check rotors, what you need to do is make sure that that rotor right there is perpendicular to grade. And the reason is if it's not perpendicular, then the water, let's say it's tilted like this, well, part of your water is going to go straight into the turf or the shrubs, and the rest of it's going to go out to wherever. So it's important to note on your punch list whether all the heads are perpendicular. Now again, we show the swing joint on the heads. That, of course, you won't see during the water coverage test. You'd see it during installation. Most of the manufacturers today have color-coded nozzles for the radius of the head. So get familiar with the color versus the radius, and when you're out in the field, stick your head down there and look to see that it's the nozzle that you specified. Also, I forgot to say that when you do a water coverage test, you might want to wear waterproof clothing because you will get wet no matter what. Okay, on the rotors, you're checking for coverage, and that has to be head to head. And when you look in a catalog of a manufacturer, they tell you that the radius is, say, 50 feet. Well, that's out to the very last drop, and when we space our rotors, we space them about 8 to 10 feet shorter than what the catalog says. So it's important to make sure that on rotors that you're really head to head, and that way you'll have good coverage. And if there's something deficient, then write it down on your punch list. Okay, now the next one, I'll tell the contractor, let's turn on A2, and that will be our pop-up sprays for this talk. And the pop-ups will be on the same thing as the swing joints. Again, you can only see that during installation, but when you're out in the field checking your spray head systems, you can check a circuit probably in about 2 minutes, but you turn it on, count the number of heads, make sure it's what you've specified, look at the coverage, check the nozzle, and these nozzles are color-coded too, so based on whatever radius you've specified. Now, to go back real quickly to the rotors, it takes about 2 minutes for a rotor to do a full rotation, and in order to see good coverage, you probably have to watch it rotate at least 2, preferably 3 times. So you might be watching each rotor circuit for as long as 6 minutes, where on spray heads you can do it in 2 minutes. The other thing to check on spray heads is beneath the nozzle, there's a nozzle in there, there's a filter, and take the nozzle off, pull out the filter, and if there's debris in the filter, make a note of that on your punch list, because that means the contractor probably has not fully flushed out the system. And sometimes what you have on your plan is changed out in the field. So if a contractor has decided to change nozzles, you make sure that whatever he's done, that you approve that he's put the right nozzles on. And the other thing to look for with rotors and pop-ups is to make sure that your overspray is not, or make sure that you don't have runoff from the overspray. And part of that comes into programming your controllers. If you run your spray heads for a certain length of time before runoff, that's the time that you will have on the controller, but you may need to do several repetitions of that amount of time so that you can keep runoff from occurring. And then I'll tell the contractor, okay, let's go to station 3, and he'll turn on station 3, and that happens to be my bubbler station to trees. Now, on your bubblers, it's either you have the stream bubblers or you might have flood bubblers, and those are easy to see. You can walk through, and if they're at every tree, then go to every tree and make sure that they are operating. Also, the bubblers don't have to be specified on a pop-up. Some cities prefer that, but usually what we'll do is put them on a flexible tube and just have the bubbler at the end of the tube. And when you do that, you can also see it pretty easy. Now, the thing with the bubblers is there's also manufacturers that make bubblers in drain tubes. That's a little bit harder to see them flowing. So what you do is you go around every single tree and you listen, and you can hear the bubbler operating. And the drain tubes, it's just hard to really see it operating. Okay, so now our next circuit will be our drip, let's say a standard drip circuit, and that's A4. And Janet is our drip specialist. So she's going to tell you about drip and what to look for. Now, you can use this button to change.
Okay. So standard drip, it's it's a little bit difficult to kind of check drip because it's so, so many emitters. So I usually just walk around and kind of check the emitters, make sure there's water's coming out. I kind of just sort of randomly check them. And then I want to check the very last emitter, make sure that the water's flowing all the way through the tubing. Make sure that that's being done. And then you want to make sure that the tubing is lined up along the plant. So we don't like to have any of the spaghetti tubing any farther than 5 feet from the half-inch tubing. So just make sure that the half-inch tubing is close enough to the plant to allow it to be not more than 5 feet from there. And then our zone 5, subsurface drip line, which is usually buried under the surface for usually 6 inches. There's a few cases where it might be on grade, so it's a little bit easier to see, but generally it's going to be buried, so by the time you get there, it's going to be buried unless you go during the installation. So what I do is I have them turn the valve on, and again, I listen. You can hear the water running through the tubing, and it makes like a little whistling sound on the tubing, and then And then we want to make sure that we check to make sure that they have air relief valves if those are required, and that's what this is down here. And when they turn the system on, you can go in, open that valve box, and you can see the air relief valve release air. And so you want to make sure that's working and that it's not leaking. And then the other thing that you want to check is the flush valve, which is usually on the farthest. Oh, by the way, the air relief valve also has to be on the highest point of the circuit. So you want to make sure that that's done. If it's not on the highest point, then they need to take it out and put it in the highest spot. And then the flush valve is usually at the lowest spot or at the farthest spot. And there's a couple different flush valves that we use, automatic flush valves or ball valves. So with the automatic flush valves, I just have them open the box up for me when they turn the valve on. We just want to make sure that there's a flush when the system comes on, and that it goes off when the system is fully charged. So if it doesn't go off, then the flush valve's leaking and they need to replace that. If they're using a ball valve for a flush valve, then you just want to have them open that ball valve up. Just make sure the water's flowing out of there without any restriction or anything like that. And this is an example of basically drip line, subsurface drip line installed before it's buried. So this is good if you can actually see this, and you can see that they have a lateral on both sides, a header and footer of the lateral pipe to connecting them, and then you can see the valve boxes over here where there's the flush valve and a air relief valve, and then the valve itself. And all flush valves and air relief valves need to be in round valve boxes, so you must make sure that those are all in valve boxes.
We're seeing a lot more of the subsurface going in because of water restrictions, but also because it's being mandated by some of these cities. Now, a couple of items that you need to check will be filters, and you would use a filter like this one would be used if you're using recycled water. This is a pretty big filter. But filters are also on all of your drip valves. You have to make sure you have a filter on that. And then there's filters under the nozzles of spray heads. And one of the things that you can do after your system is designed and installed, you can put together a maintenance manual. And in that maintenance manual, you have them check the filter at least once a month to see if they need cleaning, and that's usually during the first year that they should be doing that. And then after filters would be pressure regulators, and the pressure regulator is something that you need if you have pressure too high, or if your system is going downhill, you're going to gain pressure. So in a way, the pressure regulator, the topo, and then booster pumps are kind of all entwined with each other. If you start your system and you don't or start designing your system and you don't have a grading plan, you know, you're looking at a drawing that's flat on the screen, and if you don't have an idea of the elevation, what happens is when you go uphill, you lose pressure, not just the friction loss in your pipe, but just because of elevation. So that might be when you need to have a booster pump. If you're going downhill, you gain pressure, and again, that might be where you need to have a pressure regulator. Now, on the pressure regulators, you can have one right at your point of connection, or you can have pressure regulation at your valves. And so on the booster pump, if you spec a booster pump, you should be speccing what we call a packaged booster pump. And you as the irrigation designer will not inspect the pump. It's a pretty complicated piece of equipment, and the pump manufacturers are the ones that should come out and inspect that pump. All you need to do if you need a booster pump is tell the manufacturer what your irrigation demand is, so whatever pressure you need at whatever gallonage you need. And if the contractor, when he installs this pump, usually that's when the pump manufacturer will be out there to help with the installation. If not, if the pump manufacturer doesn't come out then when you go to do your water coverage test, just call the manufacturer of the pump and tell them a couple of days ahead of time that you're doing the water coverage and you want to make sure that the pump is working per specifications. The pumps are, as I said, complicated, and when you do have one, like I showed in one of the first slides, that if you do have a pump, it's downstream of your backflow. It can't be upstream of your backflow. Okay. So now we're going to talk a little bit, or Janet will talk a little bit about water calculations. And I mean, obviously this is not something you're going to be looking at out in the field, but it is something that's being mandated by more and more agencies because of AB 1881, which is the state water ordinance. And every city has their own little tweak on these water calcs. So Janet will talk about what's expected to be put on the plans.
Okay, usually, well, these are all from the AB 1881 Model Water Ordinance, and like Ann said, every city has their own little way of doing things, but they're all basically the same and ask for basically the same information. So you would have a hydrozone table, which would show each valve and what type of the hydrozone part would be, whether it's high, medium, or low water use. What kind of water use that plant has, and I'm sure you're familiar with that, WU calls and what the water uses are. Then what your valve number is, the method of irrigation, which is all down here and showing, and then the square footage, and then the percent of landscape area that percentage is. And with mine, I have a summary table that shows like there's a certain percentage of low water use, a certain percentage of medium, and so that we actually can meet that ordinance. So the next thing that you would be doing after you do the hydrozone table is your MAWA calculation. So this is your maximum applied water allowance. The formula's right here, so you'll need to know what the ET is for the area that you're actually working in. And there's a few resources that you can get that from. One is the Model Water Ordinance has a couple of pages on that, and CIMIS has some information on that as well. And then you just basically follow the formula, and then put in your total landscape area. And then special landscape area would be like ball fields or edible gardens, things like that are considered special landscape areas. And so there's, that formula. So then you do all your calculations. You come up with a certain gallons per per year. And then if you want to take into account the rainfall, then you can also put that here. And we usually take the full amount, the rainfall, and then use only 25% of that because a lot of it's going to be evaporated away, and you can't really consider the entire amount. And then, lastly, you have to do your ETWU, which is your estimated total water use. And this is basically the amount of water that you are planning on using based on the plant material and the irrigation methods that you're using. And this number has to be lower than the MAUA is, so that if it's not lower, then you need to change something in the design, which using lower water use plants or more drip irrigation, less overhead spray, that sort of thing. Again, the formula is right here. So you're going to use your ET again, plant factor, which is your low, medium, or high, and those are usually a number like a 0.3 for low, 0.5 for medium, and 0.7 or 8.8 for high. Turf is usually 0.8. And then your landscape area, and then you divide that in by your irrigation efficiency, which is usually, if you have drip, it's 0.9. There are charts and stuff you can find that show these numbers, or the manufacturer sometimes has the number. Rotors are 0.85, I believe, or 0.8. Rotators are 0.8. Spray heads are typically 0.7. So you need to just find your average. So you add up all your valves and find the average number on that. And then add your special landscape area in there. And then that number should actually come out. This number here should be lower than your MAUA calculation. So I think that's it.
Now, the water calcs, depending on the city's request or the water agency's request, you either actually put it on your plans, it'll be a separate sheet, or you can turn it in with your specifications. So you have to find out from the agency which way they want it, but they all want it. Believe me, you have to. This is part of the change over the last 40 years, is that we need to do all these water use calculations. And it helps us be better at water conservation, I think. Now, if you ever have any questions when you're out in the field and you're not sure what you're seeing, if it's right or wrong, we'd be glad to help you out. Just here's our contact information, and just give us a call. And then also we have a new website that Joe, our associate, just launched last week, and so we're really proud of that. Now, the one last thing I want to say to you is the more you can go out into the field and look at installation of your design, and then do a water coverage test on your design, you will end up being more familiar with irrigation, more familiar with how things really should be installed. And at the end of all of this, it'll make you better irrigation designers. So it is important to, in your fee, put in time to do these water site visits. Okay, we want to thank you for being here, and thank you because we were late. We appreciate you staying, and if you have any questions, now is the time to ask, because we have a big question mark. Yes?
So finding underground leaks, the tools that are used for that, how accurate are they and how expensive are they?
Do you have an...
I'm sorry, I didn't have a question.
No, underground leaks, how...
Like when a pipe
which,
is burst, if you're not sure, you can tell there's water being wasted somewhere, but you're not sure where.
Yeah,
Yeah,
that's difficult. Oftentimes you'll see, if it's turf, a lot of times you'll see a big bubble right where the leak
Yeah.
is, or you step on it and you can kind of feels like a little water bed.
But it's under hardscape.
If it's under hardscape, yeah, they really just have to dig it up, and that's why we put sleeves under hardscape, because that way, if there is a leak under the hardscape, sometimes you can tell if the edges of the hardscape are really wet on both sides, you can maybe figure there's a leak in there. Then you will be able to pull the pipe out, fix it, and put the pipe back in without tearing up the concrete. So sleeves are really important for that reason.
there's no, like,
Determine.
wand that you can wave over it.
I wish.
Yeah, a water witch person. There's, some of the contractors have equipment that can find broken lines, so it's best to check with a contractor on that. It's difficult because water always goes downhill. So, you know, you might have a soggy place over here, but the break is up here.
Right.
Uh-huh.
And so
Okay.
it becomes just a digging experience.
There are leak detection companies
Yeah.
that that's all they do. So
And that costs money.
Yeah.
Okay.
Okay. Anybody else? Yes.
Could you talk about the two-wire system a little bit? Are there any pitfalls to that? Because it seems like, you know, trying to add a valve after the fact is always a nightmare because you never have a wire there. Are there any reasons why? Are there any downsides to it, or is that what everybody's going to be using?
Well, to start at your last comment, I think everybody is going to be using it. The two-wire system actually has been used here in the United States on golf courses for a really long time. And then in Europe, it's been used for even longer. And I really do believe that that's all we're going to be seeing in controllers. There's the beginnings of that are that there are some manufacturers that don't make a two-wire controller system, but they make an adapter for that to happen. So pretty soon they'll be on the same page of having two wires. And then we believe that major manufacturers are going to make it so your valve has that decoder in it, so you won't actually have two pieces of equipment in your valve box. And then it's easy to add a valve anytime after that. And the downside right now in our level of irrigation, meaning something not as specialized as golf courses, the biggest downsides we've seen are contractors not being familiar with it. And so if you specify a two-wire and you think your contractor's not up to speed on it, the manufacturers are more than happy to come out and show the contractor how it should be installed. So, but to really answer that question, no, there is not a downfall to it.
And are they particularly difficult for the contractor to install? Any particular problems the contractors have installing them?
It's new and different to them. It's a change. They're not sure about these decoder items. So that's where the manufacturer can help the contractor, is getting these decoders installed correctly. But as I said, we're going to see manufacturers develop valves with the decoder in it, and that'll solve that problem.
And one other thing that's important for a two-wire is grounding. You have to
right.
make sure that they have grounded. So usually every 500 to 600 feet, they need a grounding rod, and that's really important as well.
Right.
So they sometimes forget that.
So with that, what's the big cost difference? Is it right now? Is it pretty big, or?
Well, we have done some research on that, and right now, if you have 24 or more valves, it becomes cost effective to use two-wire. If it's less than 24, then it's less expensive to use a regular controller. But that gap is starting to narrow. And again, if the manufacturers come out with valves with decoders, and eventually we'll see the multi-station wire controllers just kind of fade away, then that price difference will be nil. But when they first came out, there was definitely a certain number of valves where it made sense to use the two-wire, and a certain number that was
And that's gone down too. So when we
Yeah.
first were doing it, it was about 70
Yeah.
to 75 valves was when you did the two-wire. And now it's really come down because the cost of the controllers has come and decoders have come down. And the cost of wire has gone up, so that makes a big difference.
The first time you have to add a wire all the way back to the control, you probably pay for it.
Yeah, that's true. That's true.
Yes.
Fertilizer injectors,
Mm-hmm.
issues with clogging.
No,
Not too bad. It's
Uh-uh.
better.
no, they've, fertilizer injection has, of course, been used in agriculture for years. And now we're seeing it more in our turf industry, or what we call turf and ornamental industry. We're seeing it more because of drip.
I was gonna ask about the drip,
Mm-hmm.
because drip can be pretty sensitive.
Yeah, but it's the fertilizer injection and the fertilizer they use is now come about so that it's not a clog problem or, messing up the drip emitters.
And what kind of drip do you use? It looked like Metafin that you were using?
Well, yeah, I use mostly subsurface drip line, and then in more narrow areas where there may be only one row of plants or something like that, I'll use a single outlet drip system.
The ones that you have underground that you showed earlier, there was a plant here and a plant here, but you have openings in the pipe here in between the plants for future growth. Can you control that at all? I mean, at the beginning you do more watering than you need to.
Right. I'm not sure if I'm understanding the question, but the spacing. So the emitter drip line the emitters are spaced a certain distance apart, usually 12 or 18 inches apart, and then we space them about 18 inches apart as far as the rows go. So no matter where the plants are, it's really getting the entire area that you're watering supposedly an equal amount of water. So it's not really based on plant spacing so much. Although when I do a large area where the spacing is like 3 feet to 4 feet, then I'll go to either bubblers or a single outlet drip emitter system, because then you're just watering dirt in between. So, yeah.
That's
Well,
right.
that one photo that you would refer to,
Can you go back to that photo?
wouldn't you be covering that with mulch? That's not a subsurface.
Yeah. Well, I'm not sure which picture it was. So.
Below grade, you showed two images. One was a real world installation. Another one was a graphic, a color graphic. Like
So
this would be.
this is probably going to be turf or something like that. I'm not really sure what would be going in here, but you can see that if you planted plants at say 18 inches on center, this would be a good system to use. But if you were planting plants at 4 feet on center, then you're going to get a lot of bare areas that are going to get watered that maybe not really need to be watered.
This would be covered with soil.
Correct. Yeah, this is going to be buried 6 inches deep. Yeah.
It's covered with soil.
Right.
And this graphic, like the graphic, can you go back to that one, Ann?
There.
There.
Now
Oh,
that
yeah.
would be covered with mulch.
Probably.
Yes, correct. Yeah. So this is an on-grade drip line system. This is actually drip line. You can see the drip tubing right here. Right? But they're stapled to the ground, and then you cover it in mulch. But they're 18, probably 18 inches on center.
But if you're planting something 4 feet on center, and the plant is only as big as you showed now, then you expect the roots to eventually cover the total area as well.
Yeah, and if it's one of those like spreading plants, surely don't know that much about plants, sorry, but if it's one of those that spreads, then you might want to go with the drip line system, even though they're spaced that far apart, just because. Like a ground cover.
Yes.
Or even like I don't know what this. It looks like it might be star jasmine or something. Maybe even that. If it was spaced farther apart, you still might want to use a drip line because the roots are going to, the whole place will be filled in at some point anyway. But these plants up here are spaced fairly far apart.
Usually, what you're saying is an item where we have to decide when we use subsurface versus individual emitters. But for instance, Caltrans is going to space planting material 6 feet apart or 8 feet apart, and at that point, doing subsurface doesn't make any sense because of just what you said. You're irrigating soil. So at that, yeah, then you would just use with single emitters out to the plant.
Eventually, we need the total area to get water.
If
As the shrubs grow.
Yeah, if it's one of those spreading plants, but
Yeah.
if it's just going to be a single shrub that doesn't spread, then
I think what he's saying is the roots underneath grow,
Oh,
spread.
uh-huh.
But yeah, I don't.
How much horticulture do you know when you're designing the system?
We count on you, the landscape architect, to know that. You need to give us a class on horticulture.
Yeah, there you go.
It's very important.
Yes. Well, we
The issue in soils and how the water goes in one place and
Yes.
then it ends up over
Yeah.
there.
Mhm.
You're trying to water this plant and the roots need it here, but it's
Yeah.
sloping down because just the makeup of the soil.
Well, yeah, that's a good point. When you're doing any kind of drip, you really do need to know what your soil type is, because if it's like sand, your profile of water is going to be real narrow and long, and if it's clay, it's going to be spread out and not as deep. So, in a lot of situations where we are needing, we'll ask the landscape architect, ask you guys, have you done a soil test, so that we know what
Yeah,
we
we
should use.
really need to have that information because
Yeah.
that really basically depends on how far we space these lines and how
Mm-hmm.
far the emitters are too, depending on the soil type.
Yeah, standard specifications would call that you don't install planting until the irrigation system is fully installed
Mhm.
and coverage is checked. However,
Exactly.
here, you're better off planting
And then laying the pipe.
installing
Mhm.
the irrigation.
That's correct.
Yeah.
Now, what is the irrigation efficiency? Is it pretty low for this?
For drip line,
For-
it's the same as regular drip. It's 0.9. The
Yes.
rating, yeah, it's the same.
Do you like to put it in afterwards?
Well,
Is it really long?
Yeah.
no,
Through that.
I think what
I'm
he,
not real crazy about this.
yeah, I think what you're saying is that you as landscape architects like your plants to be in a certain spot, right? Like spaced nicely, and then if there's tubing like right here, and you want to put a plant right there, then it's kind of causes a problem for you.
Wanted installed.
Yes.
But, yeah.
Just like your
I was going to
irrigation
say the
does.
irrigation, same thing. That's why you have to go out in the field and
Yeah.
watch
you're at
what's
the
going.
mercy
Yeah.
of The quality of the
Which
installation.
Yeah.
segues into my next question, which is, what are the horror stories that you've experienced?
Oh, there's too many of them. I think one of the best ones, and this has been a while, but there was a pretty good sized system. It was a cemetery, and it was being fully irrigated, and up above was the water source, and this happened to be a 10-inch line, and it ran for a really long distance, for about 5,000 feet, and there was nothing put on the main line that would absorb any air or pressure or anything. And what happened was they turned on the pump, and there was no air relief, and then the water came down to a closed gate valve. And what happened was this entire main line, 5,000 feet of it, just shattered. And that gives you an idea of how strong water is. I mean, you have to be really careful. But I have one other kind of weird story, was that there was a system where some valves weren't working. And so we checked in the valve box, took the valves apart, and there were pieces of T-shirt in the valve box. I mean, in the valves. So that means the contractor did not flush things very well. So, I mean, the horror stories could go on. We could go on with, several hours worth of horror stories.
There's always something to punch.
So what are the most common mistakes that you see in the field that contractors, what is the most common thing that they seem to do all the time that should just be like, that's the first thing you want to go check on?
Well,
Oh, the heads not being perpendicular is a
That's-
big thing. And then on
and that's
drip,
so important.
yeah, the drip, the air relief valves and the flush valves, they either don't put them in or they don't put them in the right spot, or that's more recent because we use more drip now.
How is it being females and dealing with big burly contractors and saying, fix it?
Yeah.
Do you ever
Well,
get any
we have,
pushback, or is it-
we're very diplomatic. We definitely have good relationship with contractors.
do.
But years ago, it was difficult. The major manufacturer that I worked for, I was the spec manager, and this was in the late 70s, early 80s, and there were really no women at all. And so, I just went about my job, did it well, and met a lot of contractors and asked them questions. And so, after all these years in the business, both Janet and I have had good relationship with contractors. At first, it was a little difficult, but
So it's probably a lot, just knowing your stuff.
yep, definitely.
Yeah, I think that makes a big difference if you act knowledgeable. They're okay.
And it's,
I think they actually like walking around with the women anyway.
But one of the things is with a male contractor and a female designer. One thing like Janet says, you know your design and you know what you're doing. But the other thing is we've learned to think like a contractor, and that has helped with the relationship. So we know what they're going through, and now they reciprocate and know what we have to go through. So it's, and that's the same with all of you. You've got to have a good relationship with the contractor.
I think that we should recognize that we have today a lot of good contractors. We leave in here tonight listening to you, the landscape architects, the contractors is another person. We have a lot of good contractors.
Yes, we do. Yes, we
I've
do.
been in this business longer than anybody in this room. And when the word irrigation was hardly known,
Mm-hmm.
not that even sprinklers were hardly known, other than portable ones. And the industry owes the contractor industry an awful lot. They are growing up, but like any family, there are some not so good and others are better.
Mm-hmm.
But I don't think that we're looking for the support of the contractors to put on our repairs and so on. And I think we should not leave with the idea every contractor makes mistakes.
No,
We go to a job,
you're right.
we talk about it ahead of time.
Mhm.
We say, if you want to be paid, this has to be done properly.
Mm-hmm.
And you didn't mention anything as built plans. For example, if we have to make some adjustments in this scheme because there's a big boulder there, I want to know about it because the maintenance people later on need to know
Mm-hmm.
why that was moved. So
Yeah.
as built plans, there's a spec in my office, even if you're moving it 2 feet.
Mm-hmm.
Yeah,
Mhm.
as-built
You're
plans
right.
are very important.
Yep.
You didn't mention it. But the whole deal is,
I'll put it in my punch list to remember to do.
we need the whole industry has to work with each other.
Yes.
Architects have to work with the irrigation people. We all need to work with the contractors, we have to work with the architects, with the engineers. We have to educate our cities, because a lot of these calculations that you're going through are limited to a certain amount, certain species, and there are lots of them that are not included.
Right.
Yes,
Mhm.
For example, if you go up to Tahoe, people don't know about it. If you're using native plants of the Sierras, no building department has any idea.
Yeah.
No, you've made excellent points. And besides having a good relationship among the landscape architects, the contractors, there's also the maintenance people. They are very important. this process, and unfortunately they're even lower on the totem pole than the irrigation designer is, because nobody educates these maintenance people, and that will be coming. I mean, we've all seen what's happened with these water calcs.
In Spanish.
Yes,
Yes, exactly.
we're trying to learn that.
It's not a joke.
Yes.
No, I know.
No. Yeah,
That's-
most those classes have to be in both languages. But there's many classes out there available to the maintenance people. You just have to sort of get them to start learning more.
So, on the sensors, placement of sensors when you're trying to get weather data and rain data, whatever it is that they sense, temperature, how hard is it to place it? Because one place might be windy and another place might collect
Mhm.
humidity. How do you decide where to put those things?
It is hard to do that, and many times what happens is the manufacturer wants to be the one to place the sensor. I mean, Janet had a job where the sensor was placed near. It was for a ballpark, but it was placed near the lights that come on at night, and the sensor was reading that light,
The heat from the
the
light.
heat from the light, and so
Never would have thought, right?
yeah,
That was
So-
actually a weather station. We had,
yeah, full on weather station. So
Yeah.
it's
So we had to move it.
it's hard to just on your plans. It's hard to just say, okay, the sensor needs to go right here. You need to put a note to have the manufacturer be the one that chooses the sensor site. The sensor or the controller that we showed with that sensor, that one we were showing on top of a roof, and so it's important if you go out and look at a job site, if you see the sensor is under a tree canopy or somewhere where sprinklers get to it, make sure it's up higher on a pole or on a garage roof. But there still should be a note on your plans to have the manufacturer come and help place it. Yes.
When you're doing your, MAWA calculations, you use the state's, Department of Water Resources, ETO for that area. But when you're, scheduling the controller, you use the ETO, the current ETO, for that area. And does the contract with these smart controllers like Rainmaster, does the contractor plug in that ETO, or does that controller actually speak to SIMUS to pick up the current ETO information for that?
Yeah, the most of the controllers, well, the ones that are getting information from like SIMUS or some of the NOAA or some of the other weather stations that are around, it's automatic. They dial in once every night, I believe, and they get the data, and then they, calculate their scheduling. The controller does the scheduling and calculating. For these smaller ones, like with the weather sensor, same thing. The weather sensor, it has that little unit. I don't know if you saw that on the wall up above the controller. And that actually takes all that data from that weather sensor and converts it to ET.
Okay.
Yeah.
Humidity.
Humidity.
And wind.
It's temperature, and it doesn't do wind. Most of them don't do wind. Weather stations do wind.
Yeah.
These little smaller ones do temperature, solar, and rain.
Rain.
So that's, I guess precipitation or whatever
Yeah.
you want to call it. And so I think that's, so it's not as sophisticated as a full-on weather station would be, but it definitely gives a better data than a contractor setting their controller for 10 minutes every day and just walking away. So it definitely helps with the scheduling.
Yeah, because DWR's ETO that they list for that station is an average over
Right.
several, many
Well,
years.
Yeah, and there are controllers that are considered smart controllers that use historical data, and that's what they're using. And so they don't have any kind of anything other than that. So there are only a few of those out there, and I don't use them, but yeah. Yeah. I'm sorry.
Oh, I forgot to mention that.
Yeah, we haven't used very many of them, and they're becoming more and more popular because they're getting less expensive and easier to use, and they have wireless ones out now, which are nice. Because it used to be that you had to wire them to a valve. My problem with moisture sensors in the past is like, where do you put them? You know, and but now the controllers are getting better at reading the data, and you only need one. So you just put it in the wettest spot, I think it is, and
Hottest weather,
wettest spot or driest spot, depending, and then the controller, takes care of the information from that point. So you don't need one per valve at all. You just need one for the whole system.
Well, there's different types. I mean, sometimes if you've got a job where there's a big open sunny lawn over here and then a circuit over here that's has shade from the building, then you would put in separate moisture sensors, but you don't necessarily have to put them for each valve anymore. So they become a tool for scheduling by putting them in representative areas than other valves that are like each representative area, then they'll be scheduled the same. But definitely, moisture sensors had a bad reputation a while ago when they were used in our market, and moisture sensors have been used in agriculture for a long time. But we had kind of a number of years where they just were not working well because nobody really understood them. Now people are more educated, the manufacturers are, and we're starting to see much more use of moisture sensors. I think some of the larger manufacturers are coming out with moisture sensors as an adjunct to the smart controllers, so you can pick either way.
And I think it used to be the old moisture sensors just cut the common, and so
Yeah.
in these newer ones, they're doing more of a percentage adjustment per valve. That was something you had to program into the controller, saying this is the wettest spot, adjust accordingly, percentage-wise.
Okay, we're getting a signal. Oh, okay. Yeah, we have our business cards. Okay. We appreciate your spending the evening with us, and it's been a good experience. Okay. And Janet and I have cards. Joe is a fairly new associate, so Joe doesn't have cards yet. Yeah. Oh, okay. Really? 15 minutes saying, we're here, we're coming, we're in the elevator, we're coming.
Which subject?
And started her first phone call.
And there's a shooting. I saw that on the 511. It said
Yeah. Yeah, yeah. You know, the irony is that now with the new bay-friendly
Absolutely.
landscape requirements, they don't want you using artificial, they want you to put nutrients in the soil when you plant it, so you don't need, injectors.
3 helicopters and 2 planes flying overhead.
That's
So-
right, so I'm not a big fan of nutrients. I have a question about this. So the water use requirement for this
Freeway, I
plant
guess
is
they
less
said
than
one
this
car
plant.
is on it, and then it's